So let's continue then with the next presentation. Next presentation is MINDBOT, promoting good mental health in SMEs, adopting COBOTs. And we have with us Fabio, Storm, and Carla from Istituto Medea from Italy.
Yes. Hi, everyone.
Hello.
You can hear me?
Yes, we can.
Yes, and I also see the presentation.
Yes.
Yes, it's fine. Okay, great. Good. So thank you very much for inviting us. I'm speaking on behalf of, my name is Fabio Storm, I'm a bioengineer and researcher at the Medea Research Institute. It's a research hospital located in the north of Italy, close to Milan. Me and Carla, which is my colleague, we will speak on behalf of Gianluigi Reni, which is the project coordinator of our institution, which unfortunately could not participate today. So yeah, I'll start presenting the consortium first, which is made up of 9 institutions throughout 4 countries. We have, in particular, 3 universities, 3 research centers, 2 companies, and 1 ministry. We have in Italy, there is the University of Milan. There is the Italian Research Center, which is the biggest publicly funded research institution. And there is, of course, Medea, which is my institute. In Germany, we have the German Research Center for Artificial Intelligence, together with the University of Augsburg and KUKA, which is a large cobot and robot manufacturer. In Croatia, we have the University of Rijeka and the Ministry of Labor, Pension System, Family and Social Policy in Zagreb. And finally, we also have a startup company, which is Biorix, located in Belgium, which develops algorithms and apps to detect the mental state of people using physiological signals. And we also have the in-kind participation of Consortium GAR for what concerns the technological and informatics infrastructure. The overall ambition of MINDBOT is to promote mental health, in particular in cobot workers in the field of Industry 4.0. The aim is to do this through the identification of methods and the implementation of solutions for promoting good mental health within, especially in particular, the emerging Industry 4.0 in manufacturing enterprises in particular, that adopt collaborative robots in their production lines. So this is the specific ambition of MINDBOT. Well, I will not go into the detail, of course, of this definition, which you are all aware of. We want just to highlight here that, of course, mental health is not just the absence of mental disorders, as is stated by the World Health Organization, but is a state of well-being where the individual actively realizes his or her own abilities. This is, of course, especially important in the workplace. Another quick definition that is useful to understand our projects overall is the definition of cobot. Cobots are robotic systems which are collaborative. This means that they are machines that are able to interact safely, especially physically safely, with human workers, sharing the same task and the same space and workplace. And these cobots are increasingly being used, especially in manufacturing enterprises. In terms of scientific starting point of the project, we have seen in recent investigations that there are researchers looking into the quality of experience and the level of engagement of workers interacting with these specific type of robots, with cobots. And there is also literature looking at how people diagnosed with autism spectrum disorders interacts with these devices. However, so far, mostly cobots have been used to get optimal productivity and performance within industries. This has been done by reducing uncertainty and instability in their cooperation with humans, making them more trustworthy. However, as stated by recent literature, for example, Mulheimer in 2020, operating cobot workplaces does not automatically ensure healthy working conditions, especially mentally healthy working conditions. Prama also suggests in their work that the presence of especially social cues increases the perceived enjoyment and intention to work with these devices. So saying this, in this picture you see a typical car factory where there is very little contribution of the human worker, and this is an almost completely automated production line with robots which work within protective fences. I'm going to show you also this video. I hope you can see it. And in this, I'm not going to show you the whole video, but it's just to show you that in certain industries now, so this is a cobot here that you can see, and there are some applications where cobots are being used. There are not still not so many, so you can see here a camera on the cobot where you can see what actually the work of the cobot is. And in this case, the cobot works nearby, so on the right-hand side of the worker, and it works collaboratively on a production line. Okay, I'm going to stop this and go back to the presentation. Okay. So, said this, the overall aim of the MINDBOT project is to design workplaces where the level of challenge and the difficulty of job tasks are better matched with the workers' abilities and skills in order to support motivation and engagement in a flexible and personalized way, facilitating an active and positive attitude of the workers, and promoting, of course, good mental health, preventing any possible negative experience, for example, anxiety or boredom, which may lead to mental illnesses. In addition, we aim to intervene on technological, relational, and organizational aspects of the cobot-based work in order to foster and promote workers' mental health in these industries adopting cobots. Specifically, a second aim very important to us as a hospital is also to target the inclusion in the work context of people with autism spectrum disorder. So I'm going to present you the work plan, and then I leave the floor to Carla, which will go into the detail of the three phases of the project. In phase one, so of course we have a work package completely dedicated to ethics. And we have a phase one in which we have done a basement, and it's still ongoing actually, baseline assessment of the workers' mental health and quality of experience during job tasks involving the use of cobots. And the second work package 3, where we are looking into the analysis of working environment and organizational specifications. And then we have a work package 4, integrating all the data coming from work package 2 and 3 to provide technical specifications for phase 2, which is the technological development of the new cobot that we would like to propose in the project. this phase 2 is divided into 2 work packages. The first work package is dedicated to the development of MINDBOT technologies. The second work package will integrate all these technologies into a single device and will test this in a controlled environment. And finally, in phase 3, this new innovative cobot will be tested in some selected workplaces and in the laboratory, and overall organizational impact assessment of the introduction of this new device will be done in work package 8. And we also have a work package dedicated to dissemination exploitation and to project management. So I'll let now Carla, and she will go through the different phases of the MINDBOT project. Thank you.
Okay, thank you, Fabio, for introducing the MINDBOT project. I am Carla Dei, and I am a product and user experience designer, and I work in the research center Medea, together with my colleague Fabio. So, as Fabio said, the development of MINDBOT project is divided into 3 phases. Now I briefly introduce you the main activity of each phase. So, phase 1 aims to define a baseline assessment of the work experience, considering psychological, psychosocial, physiological, and environmental factors. So, in this phase, we recruit worker in enterprise, and we analyze this factor during a whole week of work. We analyze psychological and psychosocial factors using a subjective questionnaire that are experience sampling method, ESM, mental health continuum in short form. The participant has to complete ESM many times during the days, while mental health continuum just only one time before the whole week of observation. So we investigate physiological factors using wristband Fitbit that acquires physiological parameters and transfer them to MindStretch app. MindStretch app creates a match between physiological data and mental state. And the last type of factors that we analyzed in this phase are those regarding environment and general organization. We analyze these factors using field observation, video recordings of human-robot interaction, and structured interview. So we observe these factors also in a controlled environment. In the video, you can see the cobot in the headquarters of CNR, that is one of our partners. So for the task, it has been created an object that you can see on the left, composed by 9 elements. And the cobot has to assemble the 4 elements that you can see in the blue square on the left. So here you can see the cobot doing its pick and place task. So now it has assembly the different pieces. So when the cobot has complete is part of the object, it gives, so here you can assemble the last piece. So we put on the other 3. And the cobot gives all piece to the worker, and the worker detach the assembly from the robotic arm and complete it with the other elements. Okay, so all data and information that we acquire in this phase are analyzed and integrated in order to be a starting point and a base for the phase 2. The phase 2 aims to develop MINDBOT platform in a lab environment. The 2 main goals of this phase are developing technologies and testing them in a controlled environment. So here you can see a general overview of the main technologies involved in the MINDBOT platform. So there is Microsoft Kinect, technology that is a technology destined to human body and movement recognition. Then there is a part of technologies destined to the analysis of social cues from the facial expression of the worker. And then a part of technologies is destined to creation of interactive avatar. In all of this technology, we also considering the data that we acquired from experience sampling method and the physiological data that we acquired from Fitbit. Okay, so Microsoft Azure Kinect is a system of multiple camera and optical sensing module that have been placed around the human and the cobot. And this system gives as output high-resolution RGB image, schematic representation of human body in the form of a skeleton, as you can see on the right. And the main important output is the possibility to extrapolate biomechanical parameters related to human motion. Another part of technology, a big part of technologies, is destined to the analysis of social cues. So near in front of the worker are placed video camera, and it has been created an algorithm that analyzed the social signal acquired from video. So this algorithm is able to recognize 10 different emotions from the facial expression. On the right, you can see the full list of this emotion. This part of analysis of social cues is mainly conducted by University of Augsburg, that is one of our partners. And the last macro area of technologies are that involved in the creation of an avatar, because in the literature it has been studied that people tend to perform better in the presence of another person. And this is why we have, it has been created a human avatar instead of a fantasy one. To define the character, it has been used a computational model that is called affective user model that make avatar more believable. For now, there are being created 5 characters one with is neutral aesthetic, and the other 4 with parameters for the perception of trustworthiness and dominance. And this part of the creation of avatar is mainly conducted by our partner, DFKI. So we have to keep in mind that all of these technologies are implemented in order to be possible the adaptation of cobot and avatar to user needs. In fact, cobot has to maintain its functionality, but at the same time, it has to be human-friendly, and it has to be able to respond to the user, to the worker's needs. So the other goals of this phase surely is testing all of these technologies in a lab setting. The last phase of the development of MINDBOT regarding the implementation of MINDBOT prototype in a selected workplace. This phase is divided in 3 steps. So the first is the selection of 1 or 2 enterprises among those previously enrolled in the phase 1. Then testing the prototype with both healthy workers and people with ESD. And the last step is using a model of socio-technical system to validate the platform and produce guidelines. In conclusion, here you can see a timeline that sums up the general development of the project. So now, as you can see, we are over the half of the phase 2, and we plan to close this phase and to enter in the last phase, the phase 3, on May 2022. Thank you so much.
Thank you, Fabio and Carla, for the presentation. I think there are a couple of questions, Carrie?
Yes, Esther Kovac, sorry if I mispronounced your name, is working in the field of health work development, and they're exploring task shifting, including shifting tasks towards digital. I would like to ask, how do you see the facilitators and obstacles to collaborate with these cobots? What are the success factors to make cobots as effective co-workers? Thank you.
Thank you very much for this question. Well, actually, what we saw in the few workplaces that we visited during the first phase of the project, we actually saw that cobots are rarely employed as real cobots, so in collaborative tasks. So this is still something that is not very used. So the technology is useful often because cobots are very small, they can be placed easily in production lines without fences. So they are, from a physical point of view, they are very safe. However, they have not been used very much for their actual scope, which is to allow a closer collaboration with the human worker. So at the time, more than collaborative, these activities are often just cooperative. So they share the same area, but actually the cobot is doing something and the human worker is doing something else, as you saw briefly in the first video that we showed to you.
Thank you, Fabio. And another question from Johanna: is there information on the effect of using avatars in educational settings, for example, online courses?
Thank you for the question. Actually, this is a bit specific, probably a bit too specific for me. The activities or the expertise on avatars is in our research project is provided by the University of Augsburg, together with the German Research Center on Artificial Intelligence, specifically the second one, the DFKI. and they have extensive knowledge in the use of avatar, which are designed using artificial intelligence methods. And I can probably better refer you to some of their contact, and they surely would be able to direct you to information on specific aspects and use of avatars also in educational settings. I'm sure they have also direct expertise on that.
Thank you, Fabio. Could you leave that information in the chat so Johara can access?
Sure.
Thank you.